The development of quantum theory is often compared to triplets, which is a pretty fitting metaphor. Quantum theory grew through the work of three brilliant scientists: Werner Heisenberg with matrix mechanics, Erwin Schrödinger with wave mechanics, and Paul Dirac with quantum algebra. Each of these approaches offered a unique way to describe quantum phenomena. And later, it was discovered that they were all just different expressions of the same theory. Let's dive into their contributions. 1. Heisenberg's matrix mechanics, 1925. Werner Heisenberg was the first to come up with a formal mathematical framework for quantum mechanics using matrices. His matrix mechanics described the physical state of quantum systems using abstract matrices, where observable quantities like position or momentum were represented by these mathematical objects. One of the most famous concepts that came from Heisenberg's work is the uncertainty principle, which states that you can't simultaneously know both the position and momentum of a particle with perfect accuracy. 2. Schrödinger's wave mechanics, 1926. On the other side, Erwin Schrödinger took a different approach with wave mechanics. He described particles like electrons as waves, spread out in space as a probability wave rather than a definite particle with a fixed location. His famous Schrödinger equation became the foundation of quantum mechanics, explaining how particles evolve over time through their wave function size. This approach was more intuitive for many because it seemed to connect the quantum world to the classical wave-like behavior we already knew from light and sound. 3. Dirac's quantum algebra, 1928. Paul Dirac made crucial contributions by bridging the gaps between quantum mechanics and relativity. His Dirac equation was the first to describe particles like electrons moving at relativistic speeds. This was a huge leap because it combined quantum mechanics with Einstein's theory of relativity, allowing us to understand how particles behave at high velocities. Dirac also predicted the existence of antimatter, specifically, the positron, a groundbreaking discovery that showed the universe operates with a beautiful symmetry. His work helped solidify quantum theory as not just a theory of the very small but a theory of fundamental symmetries in the universe. Bringing it all together, initially, Heisenberg's matrix mechanics and Schrödinger's wave mechanics seemed like two competing theories. But soon, it became clear that they were just different mathematical ways of describing the same underlying quantum reality. Dirac's work took both approaches and extended them to include relativistic quantum mechanics and later quantum electrodynamics. Conclusion. In essence, the development of quantum theory was driven by these three scientists: Heisenberg, Schrödinger, and Dirac, contributing different perspectives and tools. Together, they built the foundation of quantum mechanics that we still use today. Their combined work forms the core of modern physics, explaining everything from the behavior of subatomic particles to the fundamental forces of the universe.